Okay, in this video, we're going to continue doing our Calculus 2 review. So I'm going to show you a couple questions and you can feel free to pause and do it by yourself first and then pause, play again, and come back to watch my solution. Let's begin. Okay, this is our first question. So it's basically a simple integral question, like integration question. So we can use the u substitution for this. Let u be x squared minus 4. Du will be 2x dx. So 1/2 du will be x dx. So then the original the original expression will become 1/2 replace dx with du and 1 over u. Okay, so 1 over u is just natural log of absolute value of u, right? So I can simply just like replace u with x squared minus 4 and don't forget plus c. Okay, so this is our final answer for this one. Okay, let's keep going. Try this on your phone first. So this question, we can doing the finding the dy dx, like take the derivative on both sides. So the original function will be this. Don't forget the chain rule in here. And if you take the derivative of x, it would just be 1. So divide both sides by cosine xy. It will become this. Okay, and move this y to the other side. And solving for dy dx and divide both sides by x. So okay, we can change the format of this a little bit. Okay, so the final answer will be this. Okay, so this will be our final answer for this question. Okay, let's keep going. This question gives you a graph. This is function f. The graph of the function f is shown above in here. Has a horizontal tangents at x equals 2 and x equals to 5. So yeah, right here. And let g be the function defined by g of x is equal to integration from 0 to x of f of t dt. For what values of x does the graph of g have a point of inflection? Okay, so for this question, it asks us to find the point of inflection of the graph of g. Well, it given us the graph of f, and we know that g is the integration of f. So it just means that g of x will be capital F of x, or like f of t, actually. So it asks us to find the point of inflection of g, which means we have to find the second derivative of g of x. Well, the second derivative of g of x, we already know that g prime of x will be f of t, so this graph. So g double prime of x will just be f prime of t, right? So be sure to know this relationship, it's pretty important. And so what's the way to find the f prime of the function? Well, we just need to find in what intervals does the graph is increasing or decreasing. So if we want to draw a number line from 0 to 6, f is increasing from 0 to 2 and decreasing from 2 to 5 and increasing back again. So it asks us for the point of inflection, which means that the point that f prime change signs. So it will just be 2 and 5. Okay, so 2 and 5 will be our final answer. Okay, let's move on. There's a line, x plus y is equal to k, and k is a constant. So this line is tangent to the graph of y is equal to x squared plus 3x plus 1. What's the value of k? Okay, so for this question, we know that it specifically said that this line is tangent to the graph, so which means it's a normal slope, right? Because like it's like perpendicular to the slope of the original graph, the graph of this thing. So what we can do is we can first take the derivative of this graph to find the slope of the original graph, which will be this. And let me think. So we know that k is equal to x plus y. So we know that y is equal to this. So then k will become x plus x squared plus 3x plus 1, right? So it will become x squared plus 4x plus 1. Yep, and we also know that k is equal to the, because we know that x plus y is equal to k, this function is tangent to the graph of y. So we already know that it's a normal slope, which means it's like opposite sign and perpendicular to that slope. So we know that k is in here. We can set this equal to this. But this, we have to make it -1 divided by 2x plus 3, right? Because it's positive originally, so we make it negative, and then it's perpendicular. So it's like in, so it's like 1 over that function, the whole function. Okay, so we can use the cross multiplication rule. Cross multiply each side, so we can get 2x plus 3 times x squared plus 4x plus 1 is equal to -1. And then expand this whole thing out. Okay. And we know this two can get together. This is a plus, and so the final answer will be 13x plus 14x plus 4 is equal to 0. And then we can find the zeros from this function, and we will get, I think the quickest way to do it is on the calculator. So let me get my calculator out. Yeah. So on the calculator, you can go into apps and then 9 and then plus this. So enter our function into it. And then no real roots found. Yeah, that's interesting actually. Oh wow, wait. wait a sec. Yeah, okay, I think we cannot approach this thing from this side. So we need to find another way to do it, because in this way we cannot find the k, like the real solution. So but we know that it has to have a real solution, right? So so we know that k, we can set this by setting like the relationship first. So we know that k minus x is equal to x squared plus 3x plus 1. So if we move negative x to this side, we can get x squared plus 4x plus 1 minus k is equal to 0. We can group this together. And we know that if we want to find the value of k, we must set, because we know this is a quadratic equation, so b squared minus 4ac has to be 0. So then in this case, a is 1, b is 4, and c is 1 minus k. So then the whole thing will become 16 minus 4 times 1 times y minus k is equal to 0. So then 16 minus 4 plus 4k is equal to 0. So 4k is equal to negative 12, k is equal to negative 3. Okay, so this will be our final answer. Yeah, so sorry for that that misapproach. Yeah, but this will be our final answer for this. Yeah, because in order to find k, in this case, we have to know that b squared minus 4ac is equal to 0. So this will be our final answer. Okay.